Hello everyone, welcome back to another great section of this wonderful tutorial class. Today we are going to be taking our journey into the topic integration calculus. Remember we have done limits, which is the basis of the course calculus, and we have done the integration and differentiation calculus. Now today I'll be looking at general overview on integration calculus. Now I'll be doing the first part, how to integrate different functions we have. The second part is special integrations we have for different functions and so on. Now, what is the meaning of different integration? We said differentiation is the art of finding the derivative of a function. What about integration? Integration is also known as antiderivative. It's also known as what? Antiderivative. Integration is a branch of calculus that deals with the study of antiderivatives. How to something like check the reverse of differentiation. That's what we're looking at now. The reverse of differentiation. Integration is also known as what? Reverse of what? Differentiation. We have two forms of integration. We have the definite integration and we have the indefinite integration. Now, what's the meaning of definite integration? What's the meaning of indefinite integration? Now, for definite integration, you are going to sum up what you are doing within a definite range. It's a type of integration that have limits. Both we have upper or have the lower limits. Now, integration has this symbol. This symbol, we call it the integral sign. We call it the integral sign. You can see it looks like X, but it's not X. Now, for indefinite integral, the thing will take this shape, just the integral sign. But for definite integral, you have a limit here, let's say from B to A. So this time we're integrating any function that we get from B to A with respect to a particular variable that will be there. So I'm going to show this is definite integral, and this other one that we just have this symbol is indefinite integral. You don't sum up, you just do it arbitrarily. You are not like looking at a particular spot. No, but this particular integration now we are summing up within a particular range from A to B. That's what we are doing. We are integrating within a particular range from A to what? To B. So take note of that. It's very, very important. So don't forget, we have two types of integration. We have the definite integration. We have the indefinite integration. Remember, definite integration is normally integrated within a particular limit or range. And also, we can also use this definite integration to find area under a particular curve. So if find the area that is curve, we use a definite integration for that. While this indefinite integration don't have any upper or lower limit. Now let's look at the integration of different types of functions now. Let's start from polynomial functions. The first thing, polynomial functions. The polynomial function. How to find the integration, how to integrate polynomial functions. For example, now the general formula is that if I integrate x to the power n, let me put a here with respect to x, or I integrate a with respect to x, in the sense that a and n are constants, while x is the variable, what will be the final answer to this? What will be the final answer to this? So let's go with this first one. If I integrate a number times x raised to another number, I'm going to have that number times x raised to that number plus 1 all over the number plus 1. Then I'm going to add what I call plus c. Add plus c. And what's the meaning of this c? I will explain it. Then what about this? Okay, what's the meaning of this c? That c means we call it integration constant. And it's normally used when you are doing indefinite integration. After integrating the function, you must add a constant to it because there might be a constant. Now, this integration, this is the question. If you differentiate this question, now you're going to have this. So what we are doing here, we are integrating answers from what you differentiated before. So when you differentiate a function, you're going to have an answer. If you integrate that answer, you will get back the question you differentiated before. So in case there was any constant to differentiated before that was 0, that's why we are putting plus c here. When you are doing indefinite integration, you add plus c after everything. What about want to integrate a with respect to s? If the same as there's no s here. Remember, if I differentiate a constant that don't have s, the answer will be 0. But if if I integrate a constant that don't have this x, in which I'm integrating with respect to s, the answer will be that constant times the x, or times what you're integrating with respect to, which is a times s. What is that one? That will be ax plus c. That is the answer. So let's integrate, for example, now let's say I integrate 3 dx. So what's the answer to this? This is a short way. I'm just doing shortcuts here. But everything I'm going to be doing here, just shortcuts. That's all. I'm not doing long cuts here. So you get it. I'm doing shortcuts. So this is just a shortcuts. Now we create a constant. Let's say 3 now. There's no s here. It's going to be 3 times s, 3s plus c. Let's integrate 4 dx. What will be this? That will be 4x plus c. If I say integrate 6 dy, with respect to y, that will be 6y plus c. That's what I'm trying to say. You don't be this times anything that is here. If I say integrate 7 dw, that's what will be 7 times w, 7w plus c. That's what I'm trying to say. So if you do the constant, what is going to multiply here? Why not? I'm not integrating 6x plus 3, 6s squared plus 3s plus 1 with respect to s. What will be the answer to this? The answer will be you integrate each of them respectively. That's what you do. You integrate each of them respectively. Remember, how do I integrate something that has power? If the s is having, if the unknown is having, or the variable is having power, remember how to do it. We add 1 to the power, you divide everything by that new power. If it's not having power, what you just do? If it's not even having power, you divide 0, you just make a constant there. You don't constant to multiply the power. Remember this 3 now, this 3x, this s. Anytime you see x or a number standing, there's a power there, the power is 1. But they will not put it. So if I want to integrate one, I'm going to have something like 6s, I will add 1 to this power, that is 2 plus 1. I will divide by that 2 plus 1. Plus, if I want to integrate one, it will be 3x, I will add 1 to this power, I will divide by that same power. Then plus 1, there's no s there. Remember I told you, if you want to integrate anything that matters, what do? You need to multiply the s. 1 times s, what is that? It will give us x plus c. This one is going to give us 6x power 3 over 3 plus 3x power 2 over 2 plus x plus c. So we are going to be using shortcuts. Remember, so I'm not using this one now so that you just get it. But I've already done a topic which is integration calculus, division of polynomial functions. I'll go and check it before coming back to this. But just give us question. I'm just going to be solving questions here, questions, using shortcuts and all possible methods, very fast approach. So we're going to have 3 into 6, we're going to have 2, okay? That will give us 2s cubed plus 3 over 2s squared plus x plus c. That will be the final answer. So let's say we are doing this, integral 3s plus 1 dx. What will be down to this? The answer will be what? Of the 3s what? Square over 2 plus what? X plus c. That's what. Try to do that yourself. Then let's say we want to do integrating 7s squared plus 6 dx. What is the answer to this? The answer becomes 7s power 3 over 3 plus 6x plus c. Answer. I hope you got that. I hope you got it too. So let's say we want to do something like this. Let's say we want to be integrating 6yx. Okay? Let me say 6y dx. What will be the answer to this? In which s is the only variable there. What do you have? If I integrate something like this, then s is the variable. The answer will be you have s here. Check. Is there any s here? There's no s there. I told you if you integrate anything that don't have s, what do you do? Use that stuff to multiply the s. That becomes the answer. So 6y times s, that will give us 6yx plus c. That will be the answer. 6yx plus what? Plus c. The take note of that is very important. If you differentiate this one, it says that only s is the constant. Differentiate this s, you have 6y, differentiate this one 0. That's what we are trying to say. So in the same way, if you have 6a dx, and say what is the integration? If you integrate something like this one, that will be 6a times s. What is that? 6as plus c. That's what I'm going to have. So now let's look at more questions on that. Let's go integrating 3s squared plus 2s plus 8 with respect to x. What will be the answer to the 3s squared plus 2x plus 8? What will be the answer to this? Does that become what? What will be the answer? Try and do this yourself. Try and do this. Does that become? You want to solve with your eye. Just do it. 2 plus 1, that is 3. 3 divided by 3, that is 3 cancel 3. You are going to have s cubed plus, okay, this one is 1 as power. 1 plus 1, that is 2. Divided by 2. 2 will cancel 2. That will be s power 2. You know what I'm saying? Plus 8 times s, because 8 don't have x. That's 8x plus c. That's how you solve it in exam condition. You just solve it to add. You add on to this one now. Look at what you're going to have 3. We're going to have 3s power 3 over 3 plus 2s power 2 over 2. Remember, you'll be adding 1 to the power. Plus this one don't have s, we use to multiply x. So 3s power 3 over 3, 3 will cancel 3. 2s power 2 over 2, 2 will cancel 2. 8 times s will give us 8x. That's all. R plus c. R plus c. So let's solve more questions. Integral 7 x plus 8 dx. So this one is going to give us what? 7s squared over 2 plus 8x plus c. Let's say we have 4s cubed plus 3s squared plus 6x plus 11 dx with respect to x. Integrate with respect to s. With respect to s. That'll give us. What am I going to have here? I'm going to have 4s power 3 plus 3. That's 3 plus 1. That's 4s power 4 over 4 plus 3s power 3 over 3 plus 6s power 2 over 2 plus 11s plus c. This one give us, cancel 4, s4 plus, cancel this, s cubed plus, 3s squared plus 11s plus c. So this is how you integrate polynomial functions. Now, let's look at how to do exponential functions. Let's look at how to integrate exponential functions. Exponential functions. Now, to integrate exponential functions, you have to just know the rule. That is all. This rule we did here, that rule which you have 1 to the power divided by the new power, that is only for polynomial function. Now, when we get to exponential function, we also use the rule for exponential functions. I'm going to be showing you 3 rules for exponential functions. He said that you have to follow up with the rules. That is all. Just know the rule and you are good to go. Now, we have exponential function of this exponential x dx. You have exponential function of this a raised to power x dx. You have exponential function of this a raised to power px dx. So what will be their respective answers? So these are the 3 exponential functions we are going to have in this class. So if e is the base, the answer will still be exponential x plus c. But if you have exponential a raised to power n, meaning that the base is not e, it's now a number. Let's say 3 raised to power s, 10 raised to power s, a constant over raised to power s. That's how it becomes that question divided by log of the base to base e plus c. You can also take in of the base plus c. Remember log to base e, you set it as ln, something like this. Something like this, ln. Then, what about if it's like this? You set it, you write the question out, raised to power px over this p times log of the base to base e plus c. Now let's say we have something like this. Integrate exponential 3x dx. What will be the answer? That's how we become exponential 3x plus c. But the reason why that will not become the final answer is because, look at it, because what we have here is x. What we have here is 3s, not x. So what we will now do to this 3s? We will differentiate 3s. Differentiate 3s, what is the answer? 3. Divide the answer by that 3. That will be the final answer. So if I say integrate exponential 8x dx, what we say the answer is? That's how it becomes exponential 8x over 8 plus c. How do we get this 8? Differentiate 8s, you have that 8. That's all. So let's say if you integrating exponential 10 minus 21x, what is the answer? 10 minus 21x. That will be exponential 10 minus 21x over differentiate 10, 0. Differentiate minus 21, that will give us minus 21 plus c. This minus should be here, not to be with the denominator. That will be the final answer. So what about we have to integrate exponential 11s plus 2 dx? What will be the answer? The answer becomes what? Exponential 11x plus 2 over 11 plus c. That's the answer. Please, show you know what we are doing. What about exponential 3 raised to power s dx? What am I going to have there? You have to do like this. Remember this word. A raised to power s divided by log a to base e. What is a there now? A is 3. Check. A 3. So I'm going to have 3 raised to power s all over what? 3. Okay, no. Log 3 to base e plus c. A raised to power s all over log a to base e plus c. So if I said I have integral 4 raised to power s ds, I can also write it as what? 4 raised to power what? S all over what? In 4 plus c. Remember, in and log to base e are the same. So let's say we have like this integral 6 raised to power x dx. What will you say the answer is? The answer will be 6 raised to power x over what? In 6 plus e, that is plus c. Whenever I have integral 7 raised to power 2x dx, what will you say the answer is? Integral 7 raised to power 2x dx. What will you say the answer is? The answer becomes 7 raised to power what? 2x. Now check. This question now, is it from, no, it's not from, because the base is not e. The first place. Then let's check it from here or here. Check now, we have just s here. For that one, we have 2s. So this one is coming from ps, this third one. Remember the law. A raised to power ps over p log a to be c plus c. So I'm going to have a here 7, p is 2, all over p log a to be c plus c. So let's say we have integral 6 raised to power 3x dx. What becomes the answer? To be 6 raised to power 3x over what? 3 log what? 6 to base e plus c. Answer. You are just writing question answer. This is how you roll in calculus. This is how you know. If you know you are doing that, this is how you roll. So we're going to have integral. Let's see. A raised to power 2x dx. What becomes the answer? The answer becomes a raised to power 2x over 2 log what? 8. 2 log 8 plus c. You don't have to be c. You to be skill. You know that. Now let's say we have integral 20 raised to power minus 3x to dx. What will be the answer to this? The answer is not too far from 20 raised to power minus 3x over, what you have to differentiate this minus 3, that will be minus 3 log 20 to base e plus c. That becomes the answer. That becomes the answer. So this minus will just come here. But if you differentiate 20 minus 3, yes, you will have minus 3. So that's what you're going to have. If you still integrate this, if you differentiate on back now, you're going to have that question back. So let's go. The next thing I'm going to have now, let's say we have this question integral 40 raised to power 3x. 40 raised to power 3x. What becomes the answer? The answer becomes what? How we can do that? Let's say we have integral 10 raised to power x ds. How we can do this? Let's say we have integral 2 raised to power 4x to ds. How we can do this as well? So what becomes the respective answers? And now this is what? 40 raised to power 3x over what? Over 3 in 40 or log 40 to base e plus c. So give us 10 raised to power x over in 10 plus c. Because there's nothing here to put and you have this place. So give us 2 raised to power 4x, 2 raised to power 4x over 4 in 2 plus c. That is all. The question is very simple. So it's either you use log to base e in this place of ln, or you use in, as I say in there. So take note, log to base e simply as this, see what I like is ln. Take note of that. It's very important. So this is how you run through exponential functions. Now let's look at function of a function. Let's look at function of a linear function. Let's look at functions, linear function, and also let's look at logarithmic functions. Let's look at logarithmic functions to see how to integrate those stuffs. It's a very sweet thing to do, and very nice if we know how to do them, if we know how to run through them. Then let's go. Let's go at that. So what we're doing here now is to look at something like this integration of this 5 mx plus c raised to power n dx. So how to do something like this, and integrate functions of this nature. Ms raised power n plus c raised power n dx. So if you integrate this, you're going to have mx plus c raised power n plus 1 all over the coefficient of s here. What's the coefficient of s? N. So all over that coefficient of s times this power, not this one, this new power, n plus 1, and you add plus c to it. That's what you're going to have. So let's say we have to integrate integral 6x plus 11 raised power 3. What will be the answer to this? That's how it's not far from 6x plus 11 raised power 3 plus 1 over, what is the coefficient of s here? Or we will differentiate inside. Differentiate 6x plus 11. What do you have? You are having 6 times this one, which is 3 plus 1. So that will give us 6x plus 11 raised power 3 plus 1 is 4 over 4 times 6. What is that? 24. 24 plus c. Answer. That becomes the answer. So that's how you run through integral of these types. So let's say we have, let me solve more question. Integral. Let's say we have integral 6. Let me not use 6. Let me use 9 plus 6x raised power let's say raised power 4 dx. So what we do with this? 9 plus 6x raised power. What will be the power now? I'll tell you the power. Power will what? 5. This is 4 plus 1. That's 5 over this same 5 times, what's the version of this s there? Is it 9 or 6? The version of s here is 6, which is 6 plus c. That will give us 9 plus 6x raised power what? This one is supposed to be 5 plus 4 plus 1. We just add 1 to this. You're going to have 5. So you use this 5, bring 5 here back to this place. And then you differentiate this one. You pick the question of s here. Put it there. So all over what? All over 30 plus c. Remember this 5 here. This 5 and this power. So that becomes the answer. So that's how you run through all these integration of all these types. So what about we have integral 11 minus 10x raised power 7 dx. How are you going to go about this? Let's say we have done the solving as I'm writing the question. Integral 2 plus 3x raised power 9. Raised power 9. How are you going to go about this? Dx. Let's say we have integral 22x plus 9 raised power 99. Yes. How are you going to go about this? So, you can see them. You can try them on your own now. Just remember this rule. Add up the power divided by the new power times the coefficient of let's say r plus c. Now, what is the power of it? Add on to that 7. Add on to 7. I'm going to have what? That's 11 minus 10x raised power what? Add on to this 7. I have 8. Times that 8 times the coefficient of s here. Now, which one is the coefficient of s here? Which one is the coefficient of s between these two? Is it 11 or 10 or minus 10? Which one is the coefficient of s here? The coefficient of s is minus 10 times this new power plus c. That's what I will have. So if you multiply it, this minus will go to this place, minus will go to that side. Then this one times this will give us 80. That's what I will have. It will be minus. But this minus will affect this. Or if you differentiate this, you will have minus 10 as well. So if you do this, you will have 2 plus 3x raised power. Add on to this, you will have 10 over. Now what is the coefficient of s here? Is it 2 or 3? The coefficient of s is what? It's 3. That 3 times 10 and it was 30 plus c. What about this? 22x plus 9 over. Add on to this one. That will be 100. 100 times the coefficient of s here. Which one is the coefficient of s? We're going to put the 100 there. Now 100 times is it 9 or 22 now? The coefficient of s is 22. Just pick the one that have s. Pick the one that have and stay with the s. So use 22 times 100. I'll give you 2202 plus c. That is the answer. So please take care of that. It's very, very, very important. Now let's look at integration of these types. Integral of this type, integral k dx over ms plus c. All over ms plus c. So you take note to This C here and this C here, they are not the same. This C is a constant from the question, while this other C is integration constant. So some textbook we put arrow here, we put arrow there. Which this arrow become the integration constant. Which this one will be the constant from the question. Which is all those constants here. Check. It's constant. Check this question. We have constant. Check this one. We have a constant here. We have a constant. Constant is something that don't have x. Like the constant there. Then the constant from that is in the answer. This is in the answer. And if after you have integrated a question, you just add the integration constant. So let's look at something like this. If you do something like this, what are you going to have? So if you do this, you're going to have this. And the answer you're going to have k over the equation of s here. The same just as you're doing. You want to take this k divided by the equation of s. What is the equation of s here? The equation of s there is what? N. Then you take the log of the base. What is the base here? ms plus c. This space will not be enough. The answer to this will be, let me write it this way. Write it this way. Let's see, we have this part k dx over mx plus c. That's what I have now. K dx over ms plus c. Then this one give us k over the equation of s, and you pick it, which is m. Then you take log e of the base. Which is everything base, which is ms plus c, then plus the integration constant. Let me put r. Because this already have c plus integration constant. So let's say we have integral. 5 dx all over 6s plus 11. What will be the answer to this? So what you do? This one just, if you have a question like this, you're going to solve it this way. If you have a question like this, you're going to solve it this way. So after much practicing now, you understand. After you have watched this video over and over again, you get what we are doing. You just get the different questions we are having here. So if you have something like this now, following this rule, what is the k here? Our k is 5, function of ds. Then what is m? M is what? Function of s is 6, and the c there is what? 11. So I'm going to have 5 over 6 log e of 6s plus 11 plus integration constant is what? C plus c. That's integration constant. So now I have integral 2 dx all over 2 plus 11x. What will be the answer to this? The answer will be what? 2 over, what equation of s is it? 2 or 11? The equation of s here is what? It's 11 log e of 2 plus 11x plus integration constant, which is c. Now what about, I have something like this, integral 3 dx all over 7 minus 10x. 7 minus 10x, what do you say the answer to this? The answer will be what? That becomes, 3 over what? 3 over what? Is it 3 over 10 or 3 over minus 10? This one should affect this 10 because 10 is the equation of s there. So the one that is having s is 10 and there's 10 at the minus at the back, so that minus will see show over 10. Then log of the full base, which is 7 minus 10s plus c. That's what I'm going to have. So I'm going to look at more questions under this. So look at how to integrate using partial fraction. Then we'll move on to the other stuff we have for the day. So, alright, let's look at more questions under this. Let's we have integral dx over 9 plus 6x. What will be the answer to this? The answer will be what? For this place now, our k is what? What's our k? Question of s is what? Question of ds is what? 1. It's not here. We have minor 1 here. And our which one is the m here? Our m is what? 6. This is question of s there. Guys, having s here. So we will have k over this. Then log of the base plus c. Answer. So I'm going to have. So let's say we have integral 5 dx over 10 plus 5x. So what we answer to this? We have 5 to scale over n. What's m here? 5 log e of what? 10 plus 5x plus c. 5 will cancel 5. We have log e of 10 plus 5x plus c. Answer. That's how we do this. So the next one I'm supposed to go into now is partial integration by partial fraction. So because of time, I will not be able to look at that integration by partial fraction. I will just show you how to do integration. It's just see this way. Now when you do integration by partial fraction, you have a question under partial fraction. Let me just explain it to you guys so again. Remember, if I have a question under partial fraction, let's say I have, let's say 3 plus 6. Let me just say as I have let's say 3x plus 2 all over 3 plus 3. Okay, let's say 3 plus x times, let's say s plus 3 times 6 s, let's say minus 2. That's what I just say integrate it with respect to x. So what you do, how to do this? What you do, you first of all resolve this into partial fraction. That's what you do. Remember, in mathematics, how to resolve a fraction into partial fraction. I don't know if you can still remember that. How to resolve fraction into partial fraction. So very soon we'll do a topic under partial fraction. So for resolve this one into partial fraction, how do you do that? You just equate this function, which is s plus 3. Remember the denominator is already factorized. Remember the things you consider when you do final fraction. But ensure that the degree of the denominator is higher than the numerator. And after this, you can factorize the denominator. And after that, you equate this to a constant over this first one, which is s plus 3, plus another constant, which is b, over this second one, which is what? S minus 2. So after you have resolved this into partial fraction using the normal way, want to resolve to partial fraction now, using this, just equate this to this one times this other, or you find the LCM of both sides. I'll be teaching partial fraction here. Then after that, you have answer to this, you have answer to this. You come back, put it here, you apply this. Our k here now will be the answer you're having here. Then if I want to integrate now, we now integrate this one with respect to x. So you want to look for a and b using partial fraction. Look for a and b using partial fraction, the principle of partial fraction. Using the principle of partial fraction. So you can also do that. Or should I just show you how to just do the partial fraction now? No, if you want to do partial fraction, first thing, we ensure that the higher part, the power of s here, so that the power of s is the numerator. So we check s times s squared. We have s power 1 there. So s squared higher than s power 1. The next thing you do, you factorize something is not factorized already. This is already factorized. The next thing, you find the LCM of this and this. Or if it is just 2 factors you have there, you have 2 factors there, you just use this to multiply this, and equate it to the numerator. So I'm not going to find this. Since I have just 2 factors now, I will just equate this numerator to this one times this one times this. So I'm going to have this times this. I'm having a s minus 2 plus b times this. I have b s plus 3. The next thing, we either solve this using elimination way, which you first check how can I make a or b 0. Then next thing, you get your answer out, or you just solve it with your what is it called, simultaneous equation. Solve A and B simultaneously. So there are 2 ways you do it. So if I'm going to do it simultaneously, you open the bracket. I'm going to do it simultaneously. I'm going to use the elimination method. Check how can I make this bracket 0 so that if I multiply 0 times 3, A will be 0 and B will still be empty. If S is 2, then we can eliminate that. So let's go and see what I do have. When S is 2, let's just have when S is 2. So if S is 2 now, I'm going to have 3 times 2 plus 2 is equals to A times 2 minus 2 plus B times 2 plus 3. Then I'm going to have 96 plus 98 is equals to 2 minus 2 is 0. Everything will be 0 because A times 0 is 0. Then this one I'm going to have 5 plus 2 plus 3 is 5 as 5b. We have 5b there. So next thing you have to by 5. So that b will now be equal to 8 over 5. So our b is 8 over 5. Our k there is 8 over 5. Our k is 8 over 5. Then what about the other one? The next one. What we're having as the next will be. Go back to this place again. Go back to this place. Go back to that place. Then go back to this place again. You now check how can I make B 0 now? So that A, we can look for A. Now, what will I do right to be 0? Minus 3 plus 3, that is 0. So when S is minus 3, B will be 0. So anywhere C is 2 minus 3. Remember? So when S is 2, 2 minus 2, A will be 0. Then when S is minus 3 plus 3, B will be 0. So we have 3 times minus 3, then plus 2, is equals to A times minus 3, minus 2, plus B times minus 3, plus 3. Then minus 2 plus 3 will be 0. Everything there will be 0. Then we're having this times this, that is minus 9, plus this. Minus 9 plus 2, that is minus 7. Is equals to minus, and this one is 5, minus 5. We also have minus 5. This one give us, told you this is long, that's why I have to leave it. I'll give us this one plus this one, and A will be equal to 7 over 5. A is equal to 7 over 5. So what you do, you go back to this place, put A as 7 over 5, put B as 8 over 5, then you integrate, you get your final answer. So that's how it is done. You now put 7 over 5 here, put 8 over 5 here, then integrate the 2, get your final answer. If you decide to move that over 5 over 5, leave that 5 outside, then you just solve everything out, you get final answer. So ensure you do it. So the answer becomes, it's not B, the answer to this one will be, since A is 7 over 5 over, quotient of S is 1, then log of this, plus this one 8 over 5 over, quotient of this is still 1, then log of this one, plus C. That's all. Using that same method. So try and do that. So let's do trig functions. Go up to trig functions. Trig functions. Now for trig functions, remember we have sin S, cos S, and tan S basically. So if I integrate sin X, what will be the answer? If I integrate cos X, what will be the answer? If I integrate tan X, what will be the answer? That is the first thing I'm going to look at now. Integrate cos X, sin S, tan S. Now for sin S, I'm going to have minus cos X plus C. For cos S, I'm going to have sin X plus C. For tan S, I'm going to have something very lovely. We're going to have something very lovely. Remember, I'm going to have log E of sec X plus C. That's what I'm going to have to base E. To base E of sec S plus C. Then, if I integrate cos X, that's how it be. I'm going to have log E. Remember, cos is sin S plus C. Sin S plus C. I'm going to show you how we got this. I'm going to show you how we got this later. Then, if I integrate sec square X, integrate sec square S ds, that's how we tan S plus C. So I'm going to show you how we got this and this later. Because that is not straightforward. Those two are not straightforward. So let's say I want to do integral sin 7x dx. What will the answer is? Remember, if I integrate sin S, I'm going to have minus cos S. So if you do this one, I'm going to have minus cos 7x over, differentiate this 7. That's why we're doing that exponential function that have E as the denominator. So if you use now, differentiate the 7x, you're going to have 7. You see, that becomes the answer. That becomes what? The answer. So we are still going. Then, let's say if I want to integrate cos 8x dx. That's how it becomes. Remember, if I integrate cos S, I'm going to have sin x. So if I integrate cos 8x, I'm going to have sin 8x over differentiate 8x. I'm going to have 8 plus c. That's what I'm going to have. So let's say we have integral sec squared 3s plus 4. If I do this, I'm going to have, remember, if I integrate sec square s, I'm going to have tan x. I'm going to have tan 3s plus 4. Now, differentiate 3s plus 4, but differentiate down to get the final answer. Differentiate 3s plus 4, I'm going to have 3 plus c. That's what you are going to have. These are the rules under trig function. So let's do more under this trig function before we go to integration of special types. Integration of special types of integration. Special types of what? Of integration. Special type of integration. Special type of integration. Special type of integration. Then we look at reduction formula. We have a way of solving that. Look at integration by parts. Look at integration by parts. We have a lot of things to do in this place today, so please just go with us. So we are doing trig functions now. Trig functions. Let's say we have integral cos 11 minus 5x dx. So if you do this, what are you going to have? There's no wasting of time. If I integrate cos, I'm going to have sine, not minus sine. When you differentiate cos, you have minus sine. If you integrate cos, it will be sine, not minus. Differentiate sine, you have cos. If you integrate sine, you have minus cos. Think of that too. So 11 minus 5x. Then over differentiate that 11 minus 5, what are you going to have? Differentiate 11 minus 5x, I'm going to have minus 5. Oh, just say what is the meaning of s here? Minus 5. Remember that. R plus c. So I have integral sine 2s plus 1 dx. What will be that to this? That will be minus cos 2s plus 1 over the this. You have 2 plus c. Take note of that. Now let's look at hyperbolic functions. How to integrate hyperbolic functions. That's the integration of hyperbolic. Remember hyperbolic are what? Sin x, cos x, and so on. So if I integrate sin x, what am I going to have? Integrate sin x, what am I going to have? I'm going to have cos x, there's no minus, you'll see. If I integrate cos x, I'm going to have sin x plus c. There's no minus for this. But I still follow the same rule with this trig function. As you say, integrate now. The same thing for. But one thing about it is that this one don't have minus. That's what you should know. This one don't have minus. I just say integrate sec square s is give it an L, right? Integrate sec square s. The answer will still be sin s plus 2. That's what I still go around. So let's say we are integrating integral cos. You don't have this now. 11x plus 3 dx. What will be the answer? If I do cos s, I'm going to have sin x. So the problem is 11x plus 3. We don't differentiate, just as we are doing for trig, the same thing. Differentiate 11x plus 3, I'm going to have 11 plus c. I say integrate cos 5x. Integrate cos 5x, I'm going to have sin 5x over differentiate 5x, I'm going to have 5 plus c. So that is very, very important. The whole idea, if I say integrate sin 11 minus 6x, what will be the answer? Ds. That becomes cos 11 minus 6x over is the way of integrating this over differentiate 11 minus 6x. So you have 11 0 differentiate minus 6x. I'm going to have minus 6 plus c. That's what you are going to have. So this is how you do for trig functions. Now let's look at special form of integration now. Special forms of integration. Because there are much. Look at special forms of integration now. Then we go to integration by parts.